Hi, I'm Kathy Stark. In this lesson, we introduce a larger number system called the complex number system and look at how to operate on numbers in the system. Here's where we begin. We define something represented by the letter I to be the quantity, the square root of -1. You can think of the letter I as the first letter in the word imaginary. The idea is that in the complex number system, numbers are not real, although real numbers can be considered complex. We'll work on that in a little bit, but let's begin by seeing where I comes from. Let's work through this example. What we want to do is write each of the following radicals without negative radicands. That means without negatives underneath the radical. Let's work on part A first of all. Part A says the square root of -100. We can break that into two pieces. The square root of -1 times the square root of 100. The square root of -1, as we wrote down earlier, is represented by the letter I. The square root of 100 is 10. Conventionally, we write the I to the right of the number. That's 10I. Here's another example. This says 5 plus the square root of -4. The 5 we'll leave alone, but we'll break the square root of -4 into two pieces. Square root of -1, square root of 4. Again, the square root of -1 is represented by the letter I. The square root of 4 is 2. The last piece of this sum needs to be written in the order 2I. I'd like you to try a problem using I. What I want you to do is write the following without a negative radicand. Stop the tape and work the problem, then restart the tape to check your work. Let's see how you did. The negative outside the radical remains negative and outside the radical. We're going to break the radical into two pieces. The square root of -1 times the square root of 400. Again, hold the negative outside the radical. Simplify the square root of -1 to I, and the square root of 400 is 20. The conventional way to write this is to write the I to the right of 20. The result is -20I. I is the square root of -1. I is the building unit of the complex number system. Complex numbers are numbers that can be written in the form a+bi, where a is the real part, or is called the real part, b is called the imaginary part, and I again is represented by the symbol square root of -1. Let me give you a couple of examples of complex numbers, numbers written in this form. Things like 5 plus 3i is one complex number in which a is 5 and b is 3. A number like -7 minus 2i is also in that form. A number like 2 is a complex number. It has 0i attached to it. And a number like -2i is also in the form a+bi. It's as if there is a 0 replacing the a. What we want to be able to do is operate on complex numbers, doing the operations of addition, subtraction, multiplication, and division. Here's an example of an addition problem. What we want to do is add 3 plus 2i and 4 minus 3i. The procedure for performing the addition is to add the real parts of the complex numbers and add the imaginary parts of the complex numbers, imaginary parts. Let's see how this procedure works for the example given. The real parts in the two complex numbers are 3 and 4. We want to add them together. The imaginary parts are 2i and -3i. We want to add them together. The result of adding the real parts is 7. To add the imaginary parts, treat this like a combining like terms problem. 2i minus 3i is negative 1i. This number is better written in the form 7 minus I. The second operation we want to review works in almost the same way. It's subtraction of complex numbers. Here's an example. What we want to do is subtract, as indicated, and write our result in standard form. Standard form, by the way, is the form a plus bi that we've been using. To do subtraction, there's only one step that precedes an addition problem. We'll rewrite the subtraction as addition by distributing the negative 1 through the second complex number. Here we go. I'm going to rewrite the problem as negative 2 plus 3i and distribute negative 1 to get plus 4 and minus 3i. And now what I need to do is add the real parts, the negative 2 and 4, add the imaginary parts, 3i and negative 3i. Simplifying, I get 2 plus 0i. It's also okay to write your answer as 2, and that is the complex number written in standard form. Well, it's your turn to try a problem again. Here's what I'd like you to do. Subtract as indicated and write the result in standard form. Stop the tape and work this problem, then restart it to check your work. Well, the first thing that we need to do to work this problem is to distribute the subtraction symbols through each of their complex numbers. Let's rewrite the problem as we do that. We'll have 2 minus 5i, minus 3 minus 4i, and then plus 2 minus I. Again, we want to add the real parts, 2 minus 3 plus 2, and we want to add the imaginary parts, negative 5i, negative 4i, and negative I. Simplifying these, the real parts add to 4 minus 3, which is positive 1. The imaginary parts add to negative 10i. Writing that in standard form, I have 1 minus 10i as the result. We're ready to move on to multiplication. I want to give a little bit of an explanation of a multiplication before we jump into an example. Recall that we started with I equal to the square root of negative 1. If I square both sides of this statement, I end up with I squared on the left, and squaring undoes a square root and leaves me with negative 1. This is one piece of information that we need to remember when we multiply complex numbers. As far as a procedure to use the distributive property to multiply. Keep these two things in mind as we work the following example. Here's what we're going to do. We want to multiply, and we want to write the result in standard form. Let's begin. Using the distributive property, I'm going to take the square root of 6 times the square root of 6, then the square root of 6 times negative I, then positive I times the square root of 6, and then I times negative I. Simplifying each individual term, the square root of 6 times the square root of 6 is 6. It's actually the square root of 36, which simplifies. The next term is negative the square root of 6 times I. Be sure your I doesn't look like it's in the radical. And then I have positive the square root of 6 times I, and then minus I squared. There's two more things that we need to do. We need to combine the like terms in the middle, and we need to replace I squared with the negative 1. Let's do those. Keep the first 6. The like terms in the middle add to 0, and I have that minus negative 1. 6 plus 1 is 7, and that's the result of this multiplication. Again, it's your turn to try a problem. What I want you to do is multiply this pair of complex numbers and write your result in standard form. Stop the tape while you work and restart to check yourself. Let's see how you did. Using the distributive property, 2 times 2 is 4. 2 times negative 3i is negative 6i. 3i times 2 is positive 6i. And then I have 3i times negative 3i. That's negative 9i squared. I'm going to combine the middle terms and replace the I squared with negative 1. That gives me 4, the middle terms add to 0, minus 9 times negative 1, which is the same as 4 plus 9, or 13. We're ready to move on to division. Before we can go through a procedure for division, we need to define complex conjugates. Complex conjugates are complex numbers that have the same real parts but opposite imaginary parts. I wrote a pair of complex conjugates here. Let me give you another example. 5 plus 3i is the complex conjugate of 5 minus 3i. Same real parts, opposite imaginary parts. There's an interesting feature of the TI-83 that I'd like to show you right now before we go on to division. This is what we're going to do. On our TI-83, we're going to find an option called conjugate and put in a complex number. Before we do so, let's predict what the answer will be and see if it is. The conjugate of 16 minus 24i has the same real part but opposite imaginary part. We expect that to be the result. Let's try it out on a calculator. On a calculator, the operation called conjugate is found behind the math button. If you push the math button, here's the menu that you see. We want the option called complex, CPX. It's option 1. Next to that, I'm going to put 16 minus 24i. Go ahead, put in 16 minus 24. And then in yellow on the keypad, behind the decimal point is an I. Push second I and close the parentheses and enter. And this is the result that we expected to see. Well, this is related to division in this way. If we want to divide complex numbers, what we need to do is multiply the numerator and denominator of the division problem, which you'll see will be written as a fraction, by the complex conjugate of the denominator. Let me show you what that means with an example. Here's a division problem. Notice it's written in fraction form. We want to write the quotient, the answer to the division problem, in standard form. What we need to do is multiply the numerator and denominator by the conjugate of the denominator. Here we go. The conjugate of the denominator is 1 minus I. That's the thing we multiply by the numerator and denominator of the division problem, or the fraction. Multiplying out the numerator, I end up with 1 minus I minus 3i, and then plus 3i squared. Underneath, 1 minus I plus I minus I squared. On top and bottom, I'll combine like terms and replace I squared with negative 1. That gives me 1 minus 4i plus 3 times negative 1 over 1, and notice that the i's combine to 0 in the denominator, but I still have minus negative 1. Back to the numerator, 3 times negative 1 is negative 3. If I add that to the positive 1 to the left, I end up with negative 2, still minus 4i. Underneath, the result is 2. To get standard form, I'm going to put the 2 underneath each piece of the numerator and simplify the fractions to negative 1 minus 2i. This is the answer to the division problem in standard form. It's your turn to try a division problem. What I want you to do is to divide as indicated, write your answer in standard form, and then try to support your result on a calculator, and I'll help you with that after you try it. Stop the tape and then restart it to check your work. Let's see how you did. We need to multiply the numerator and denominator by 4 minus 3i. Let's do that multiplication. We end up with negative 24 plus 18i plus 32i, then minus 24i squared. Underneath, 16 minus 12i plus 12i, notice those add to 0, minus 9i squared. Combining like terms and replacing I squared with negative 1, I get negative 24 plus 50i minus 24 times negative 1. Underneath, 16 plus 0i minus 9 times negative 1. Simplifying the numerator, negative 24 times negative 1 is 24, plus the negative 24 is 0, but I still have 50i. Underneath, I have 16 plus 9, which is 25. This reduces to 2i, the answer to the division problem. Let me show you how that might have worked on a TI-83 graphing calculator. This is exclusive to the 83. If you select your mode option, at the very bottom of this screen, second to bottom row, there is a real a plus bi and re to the theta I option. I want to highlight a plus bi. My calculator is set to operate in a plus bi mode. I'm going to quit and clear my home screen and write in the division problem. It is negative 6 plus 8 and then second I, close parentheses there, divided by open parentheses 4 plus 3 second I, close parentheses. If I enter, I see that the result is 2i. The nice thing about this mode is that the answer is automatically given in standard form. There's one more pattern that I want to go through in the complex number system, and it has to do with powers of I. There are 4 values that a power of I will take. We know that I itself is I. We've determined that I squared is negative 1. To figure out the value of I cubed, I'm going to take I times I squared, which is I cubed. Above, I already know that I squared is negative 1. This is negative I. I to the 4th is I times I cubed. I cubed is negative I. This is negative I squared, which is negative 1 or 1. The pattern is that powers of I will be one of the following results, and the pattern repeats. Let me do one example of this so that you have something to work on. Suppose we wanted to simplify I to the 32nd power. I'm going to break this into a power of I in one of these 4 sets. You might consider it I squared to the 16th power. I squared is the number negative 1. Negative 1 to an even power is positive 1. In this section, we've worked on complex numbers. We defined the complex number system, we know standard form, and we practiced how to add, subtract, multiply, and divide, and looked at powers of I. Be sure to work many problems from the exercise set of your textbook to practice with I.